Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Tifr, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the eighth part of this series of CSIR Net Physics 2021 paper solution. Okay, in which I'm going to discuss part C questions. Okay, part B questions are completed. Okay, so also guys, before starting the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. And also guys, please share my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, so let's get started. So first question of the day. Question is, the Newton-Raphson method, the Newton-Raphson method the Newton-Raphson method is to be used is to be used to determine the reciprocal of the number x equal to 4. Okay, if we start with the initial guess, the initial guess 0.20, then after the first iteration after the first iteration the reciprocal is okay. Options are, option A is 0.23, option B is 0.24, option C is 0.25 and option D is 0.26. Okay, so this is the question, guys. So I'll read the question for you. A very good question. Okay, so the Newton-Raphson method is used. Okay, the Newton-Raphson method is to be used to determine the reciprocal of number x equal to 4. Okay, so the reciprocal of number x equal to 4 means 1 upon 4. Okay, reciprocal of 4 is 1 upon 4. Okay, if we start with initial guess, we have been given initial guess. Okay, initial guess is given 0.23. 20. Okay, then after first iteration the reciprocal is. So after first iteration we need to find the reciprocal. So very good question. I'll solve now. Okay. So we have been given x equal to 4. Okay, so reciprocal of 4 is going to be, that is very important step. Okay, reciprocal is going to be x equal to 1 upon 4, right? That is the reciprocal. Or we can write this, or we can write 1 upon x equal to 4, right? We can also write this like this. Okay, that implies the fx value is going to be 1 upon x minus 4. This is important step, guys. You need to note down, because we need this function first. If you know this, then we can easily solve this question. Okay, so this is one. So we have given x equal to 4, and we need to find its reciprocal, right? The reciprocal of this, suppose let reciprocal of this is x equal to 1 upon 4. This is 4, means reciprocal is 1 upon 4, right? Or this condition we can write like this as well, 1 upon x equal to 1 upon 4. Okay, and that implies the fx is x minus 4. Fx equal to x minus 4, right? Now very simply, it is now simple thing. Now we have x, the initial guess is given, right? That is x naught is given, that is we know that 0.20 given in the question. Okay, so now it means this is fx, so f x0 we can find out from here. So 1 upon x minus 4, 1 upon x minus 4. Okay, 1 upon x minus 4 means we can write that is equal to 1 upon x value is this. Okay, so this is 0.20 minus 4. Okay, no, this is not good. So this is the fx equal to 1 upon x minus 1. Yeah, this is the correct one. Yes. So if you solve this, this is going to be so this is going to be 5. This one 5 minus 4, and this value is going to be 1. So fx0, fx at x equal to 0, that is fx0 value is this. Okay, so now this is the fx0 value. Now we will find f dash x. F dash x is going to be, this is fx, guys, 1 upon x minus 4. F dash x is going to be minus, since we have like this one, right? Fx equal to 1 upon x minus 4. So it means f dash x is going to be minus 1 upon x square, right? This is the differentiation. And then f dash x naught is going to be minus 1 upon x square at x equal to x naught. We have been given this, right? So this is going to be 1 upon minus 1 upon x square, means point 0.20 whole square, right? And this value is going to be, if you solve it, this value is going to be minus 25. Okay, minus 25. So now we have a formula for first iteration, right? X plus 1, Newton's Raphson's iteration formula. This x plus 1 equal to x naught minus fx naught, or we can write like this. This formula we have xn minus fxn upon f dash xn, right? f dash xn. Okay, so this means the x1, that first equation, that is going to be x1 equal to x0, x0 minus, this is important formula guys, you need to note down. Okay, so this is going to be x0 and this is fx0, fx0 upon f dash x0, right? So x1 value is going to be x0 value. This is 0.20 minus f fx0 value we have found here, 1 1 upon f dash x value minus 25, right? So x1 is going to be, that's for first iteration value, x1, this value is going to be, x1 value is going to be this one. We'll solve it. So 0.20 plus 1 upon 25, right? So this is going to be, okay, this is going to be 0.20 plus 0.04, right? This one 0.04, and this value is going to be 0.24, 0.24. Okay, so 0.24 is the answer. So which option is matching, guys? Option B is matching. So option B is the correct option. I hope guys you have understood it. Okay, now next question, guys. Okay, so these are very good questions. Okay, next question is, question 2 is, this is also good question, guys, very good question, and this question is from classical mechanics. Okay, so question is, a fulcrum, the fulcrum, the fulcrum the fulcrum of a simple pendulum, fulcrum of a simple pendulum, simple pendulum, the fulcrum of a single pendulum bracket consisting of mass m attached to the support, attached to the support by massless string, by massless massless string by massless string of length L, massless string of length L oscillates vertically oscillates vertically as sin zt equal to a sin omega t. Okay, where omega is a constant. Omega is a constant. Omega is a constant. The pendulum moves in. The pendulum moves in a vertical plane in a vertical plane and theta t denotes its angular position. Its angular position with respect to the z-axis, with respect to the z-axis. Okay, a figure is given. This is the thickness. Okay, this is z-axis. This thickness is z, and this is the pendulum. Okay, this angle is given theta t, which is function of t, theta t. Okay, I can show you this angle is theta t. Okay, this angle is theta t. The mass is m. Okay, and then if if L d squared theta upon dt square plus sine theta g minus ft G minus ft, f which is function of t, okay, is ft equal to 0. Ft equal to 0 where g is acceleration due to gravity, acceleration due to gravity. Okay, so this equation describes this equation describes the equation of motion equation of motion of the mass then then ft is ft is option a omega square cos omega t, option b is a omega square sin omega t, option c is minus a omega square cos omega t, and option d is minus a omega square sin omega t. Okay, so these are the options. This is a very good question, guys. I'll read this question for you. The question is the fulcrum of a simple pendulum. Okay, so simple pendulum consisting of mass m attached to the support by massless string of length L. Okay, oscillates vertically as sin z equal to a sin omega t, where omega is a constant. Okay, the the pendulum moves in a vertical plane. Okay, and theta t denotes its angular position with respect to z axis. Okay, if L into d square theta upon dt square plus sin theta g minus ft, f which is function of t equal to 0, where g is the acceleration due to gravity, describes the equation of motion of the mass. Okay, then ft you need to find out. Okay, so very simple. So we have given this figure, guys. Okay, so this thickness is z is given, which is function of t. Okay, and this is z axis given, and this is the pendulum. Okay, mass of this pendulum is m, and this length is l. Okay, and this angle with vertical is theta, which is function of t. Okay, so this oscillates vertically. Okay, and now we have been given the equation of the motion of this mass. Okay, and this is this, right? Now we need to find out the value of ft. So this is the question, guys. So I will solve it. I'll solve now. Okay, so It's a good question and I'm going to solve it, guys. So we have this figure, guys. Okay, this one. This is Z, this thickness. Okay, and this is Z axis, and this is the bob. Okay, this length is L, and this is theta, which is function of T. Okay, this length is L. Okay, so this one. This is the figure given. Okay, and we have given equation of motion of this bob, this mass. Okay, this mass, and okay, and we have to find value of Ft. So what we are going to do is we are simply first find will will get the Lagrangian for this system. Okay, and then we'll get the equation of motion for this mass, and we'll compare with this the equation which is given in the question, and then we'll find the Ft. Okay, so Lagrangian for this is going to be so we are going to take this Lagrangian uh, in cylindrical coordinate. Okay, cylindrical coordinate system. So here you need to understand this distance. Okay, this is like this. So this distance is going to be L cos theta, right? And this distance is going to be L sin theta, right? This is L sin theta, and this is Z. Okay, so this height is L sin theta, and this height was, and this we are taking as origin. Okay, this point we are taking as origin. So this height from this side is going to be L cos theta plus Z, and so the coordinate of this at this point, the coordinates are going to be right. Okay, so now we can write the generalized coordinates. Okay, simply we'll write this one first, a Lagrangian for given system. Okay, so Lagrangian generalized coordinates are, I'm writing here generalized coordinates. Generalized coordinates are this one, L sin theta, comma L sin theta, comma L cos theta plus Z. Okay, or this is minus L cos theta plus Z. Get this distance. Okay, so at this point, if we do distance, okay, so at this point, L sin theta and this. Okay, so now we'll find this one. So Lagrangian. So Lagrangian in this coordinate system in okay, so Lagrangian we are going to get cylindrical coordinate system for this system is going to be for this system, that is half m L squared theta dot square. Okay, plus Z dot square minus L theta dot Z dot, I'll write here, Lagrange is going to be this is half m this is L square theta dot square plus Z dot square minus L theta dot Z dot L theta dot Z dot, and this one sine theta. Okay, so this is the Lagrangian, guys. Sine theta, this is because Lagrangian we know, right, that is T minus V. So this is minus, and this is going to be this height, right? This height from here, this height. This height is mgh, right? So this is going to be mg L cos theta plus Z. mg L cos theta plus Z. mg L cos theta plus Z. Okay, so this is the Lagrangian, right? This is the T. This is half m for this system in cylindrical coordinate system. So this is going to be half m L square. This you need to understand. Okay, half m L square theta dot square plus Z dot square minus L. This is L. Okay, L theta dot Z dot sine theta minus mgh, right? This height. So mgl cos theta plus Z. Okay, so this is the Lagrangian for this system, guys. Okay, so now what we can do is we have to find the equation of motion, right? So we'll find del L over del theta dot, right? So this is going to be now implies del L over del theta dot value is going to be. So we have the Lagrangian for it. Okay, so this is the Lagrangian for this system. Okay, half m L square theta dot square plus Z dot square minus L theta dot Z dot sine theta. Okay, and minus mg L cos theta plus Z. Okay, this one. Okay, now so this value is going to be, so we'll differentiate this this with respect to theta dot, right? So this is going to be, if you differentiate it, theta dot means 2 theta dot 2 will get cancelled, right? So m L square theta double dot. Okay, so this is going to be m L square theta dot minus, next is this will be 0, and this is theta dot means LZ dot sine theta, LZ dot sine theta. Okay, now we'll find d over dt del L over del theta dot, right? So this value is going to be this one. This is going to be m L square theta double dot minus L. This is going to be L Z double dot sine theta. There are two functions, right? Theta and Z. Sine theta minus, and this is going to be simple one. L Z dot sine theta is cos theta and theta dot. Okay, this is the differentiation. Okay, so this is now we will find this Lagrangian. We can say this is equation number 1. Now we are going to find this del L upon del theta. Okay, del L upon del theta. So this is going to be del L upon del theta means this value. This value will be 0, this value will be 0, this will remain. So this is going to be L theta dot Z dot sine theta is cos theta dot, right? So this is going to be, and m is also will be there, guys, because m is here, right? M. So this will be m and this m. Okay, so this is going to be m L square theta dot square which is this one, minus ml z double dot cos theta. This one, this is 0, this is L theta dot z dot cos theta, right? ml theta dot z dot ml theta dot z dot, okay, ml theta dot z dot cos theta, because we have differentiated it, right? This one L, these are constant, and sin theta is cos theta, and cos theta theta dot, right? And here this mgz is going to be 0, and this is going to be this one. So this is mgl cos theta is sin theta and theta dot, and minus minus plus, okay, so this value is going to be plus, okay, minus mgl sin theta, because here you can see this one, this is this one, right guys, this one, this is minus, and this is also minus. Minus sin theta is minus minus plus, okay, cos theta, sin theta, this one. Here we have made mistake, so this is Lagrangian, this will be plus, right? T plus v, L equal to T plus v. This mistake we have there, okay. So this one, not T plus v, L equal to T minus v is correct. Here we have made one mistake, so this is minus, right? This is minus, so minus minus plus, this is plus, because this is minus L cos theta, right? The coordinate of generalized coordinate at this point, okay, minus L cos theta, so minus minus is going to be plus. This is plus, and this is going to be like this, or I can write like this one, minus mgz. We can write like this as well. So this is equation 1, okay. So if you solve it, so this is going to be mgl sin theta, okay, minus. Now we know the equation of motion, right? Equation of motion is this one, d upon dt del L upon del theta dot minus del L upon del theta equal to 0. This is equation of motion. Now we'll put these values here, okay. So if you put these values, so this is going to be, implies, if you put the values, this value is going to be this one, minus this value right here, this one, ml square theta dot ml square theta double dot ml square theta double dot minus ml square theta double dot minus ml z double dot sin theta, this one, ml z double dot sin theta minus ml z dot cos theta theta dot, right? Minus ml ml z dot theta dot cos theta plus, now this value minus minus plus, right, plus ml theta dot z dot cos theta, ml z dot theta dot cos theta plus mgl sin theta. Okay, this one mgl sin theta, right, and these values are going to be plus because this is minus sign, minus minus plus. Okay, this will get cancelled, guys. Okay, so then this equal to 0. Okay, so equation is going to be now ml square theta double dot minus ml z double dot sin theta minus 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 plus mgl sin theta equal to 0. Okay, now guys, so we have been given z. So guys, here the question, it is given like this. Okay, so this one, so sin z equal to this, actually this is z, this should be z equal to a sin omega t. Okay, so this should be z equal to a sin omega t, so you can correct it. This is in question, this is given, but this is actually z equal to a sin omega t. Okay, so now what we can do, since z equal to given a sin omega t, before that what we can do is we can simplify it further. So ml, we can see there is ml in this in all the terms, right? So we can divide by ml, so this is going to be l theta double dot minus z dot sin theta plus g sin theta equal to 0. Okay, this one. Now guys, we have been given, since z value is given, guys. Okay, z value is given a sin omega t, this one. By mass consisting of length and oscillates vertically with z equal to this, where z is the omega is frequency, right? Omega is constant. So this is a sin omega t. So it means z dot is going to be uh, a omega cos omega t, right? And that implies z double dot value is going to be a omega square cos omega t, a omega square cos omega t, sin omega t. Cos differentiation is sin, and this would be minus sin omega t and minus sin omega t, right? This is the value. Now this z dot value we can put in this equation number 2. Okay, so then this equation is going to be l theta double dot minus z sin, z dot is minus minus plus. Okay, minus minus plus, so a omega square sin omega t plus a omega square sin omega t sin theta. We have just put the value here. Okay, sin theta, this one. Okay, sin theta, this is minus minus plus. Okay, and plus g sin theta equal to 0, or we can write l theta double dot, we can take sin theta common. Okay, sin theta, then it is going to be this g plus a omega square sin omega t, we can write in this fashion, right, equal to 0. So this is the equation. So we have got this equation from the question. Okay, so we have solved that question and we've got this equation of motion, and according to question, the equation is given, equation of motion for the system is given, that is, since we have been given this one, they have been given. The equation of motion is given. This is given. We have, as per the question, equation of motion is given L square d2 theta upon dt square, or theta double dot we can write, plus sin theta g minus ft equal to 0. Okay, so this is given. G minus ft equal to 0, this is given. Okay, so if we compare, so minus ft is going to be equal to this, right? This value. So minus ft value is this one, a omega square sin omega t, a omega square sin omega t, and from here ft value is going to be minus a omega square sin omega t. So this is the answer. So which option is matching, guys? Option D is matching. Okay, so this is minus a omega square sin omega t, minus a omega square sin omega t. Okay, so this is the answer. I hope, guys, you have understood it. It's a good question, guys. So next question I'm going to solve. So this is a good question, guys. I would request you practice this question, guys. Okay, this question is from classical mechanics, because I'm solving part C questions, guys. Okay. Okay, now next question. Next question is, it's also a good question, guys. So this question is, the energies, question third, the energies of a two-state quantum system, of a two-state quantum system, two-state quantum system two-state quantum system are E naught and E naught plus A h cut, okay, or alpha h cut we can say, where alpha is greater than, this is alpha, okay. Alpha is greater than 0, is a constant, greater than 0 is a constant, and the corresponding normalized state and the corresponding normalized state vector, normalized state vector Normalized state vectors are cat 0 and cat 1 respectively. At time t equal to 0, at time t equal to 0, when the system is when the system is in the state system is in the state 0 cat 0, okay, the potential is altered, okay, the potential is it's a formula based question, guys, okay. The potential is altered by a time independent by a time independent term time independent term term V such that one V 0 equal to h cut alpha upon 10, the transition probability the transition probability to the state 1 to the state 1 to the state 1 at time t, which is less equal to 1 upon alpha, is, okay. Options are, option A is alpha square t square upon 25. Option B is alpha square t square by 50. Option C is alpha square t square by 100, and option D is alpha square t square upon 200, okay. So this is the question, guys, a very good question, okay. Question is, I'll read it for you. The energies of two state quantum systems. So we have two state quantum system, and whose energies are E and E plus alpha h cut, okay, where alpha is greater than 0 and is a constant, okay. and the corresponding normalized state vectors normalized state vectors for those energies are 0 and 1 respectively. Okay, cat 0 and cat 1. Okay, at the time t equal to 0, when t equal to 0, the system is in the state, that 0 state. Okay, and the potential is altered by independent time independent term. Okay, so we have, what we have done is, the potential is altered, okay, by time independent term. Okay, so v such that time independent v, okay, such that 1v0, okay, 1v0, that potential v, this value we have been given, that is h cut alpha upon 10. The transition probability of the state 1 is, transition probability of state 1 we need to find out. Okay, this one at time t less equal to 1 upon alpha. Okay guys, so let's solve it. So I'm going to solve it. So guys, here as a formula, so we need to find transition probability from 0 to 1. Okay, this is a formula, that is 1 upon h cut square, you need to note down, and this is 1v0 mod square of 1v0. Okay, then mod of integration 0 to t e to the power iota e1 minus e naught by h cut dt, h cut t into dt. Okay, this is a formula, guys, transition probability formula from one state to another state. Okay, this you need to note down, this one, and this you need to know where omega value is, omega if, we say omega if, we can write this value is e1 minus e naught by h cut. Okay, this is the formula, guys, we need to note down. Okay, now very simple, we'll put the formula, we'll put the values in formula, right? So 1 is going to be 1 upon h cut square, this value is given. Okay, so 1v0, that value is given, that is we have been given value, so we'll put it. So this is going to be h cut alpha upon 10 whole square, it is going to be, right, because this value is this given, this value is h cut alpha upon 10. Okay? And then whole square, then 0 to t, and this value is going to be e to the power iota, right, e to the power iota, and e1 minus e naught value we know, because we have been given e value e naught values e naught, and e1 value is e naught minus alpha h cut, right? So e naught minus alpha h, e1 minus e naught is going to be alpha h cut, right? So this value is going to be iota alpha h cut upon h cut, right, t dt, and this is mod, and this is mod square. So this value is going to be p0 to 1, this value going to be 1 upon h cut square, this is h cut square is going to be cancelled if you open this square, so this is going to be alpha square upon 100, and mod of integration, this we can write 0 to t e to the power iota alpha t, because h cut will get cancelled, and dt, right? So from here p to 1, p0 to 1, this value is going to be alpha square upon 100 into integration 0 to t dt mod square r. Why? Because this one, e to the power minus alpha t, e to the power iota alpha t, this value is almost equal to 1. Why? I'll tell you. Almost equal to 1 because since this is given in the question, t is less equal to 1 upon alpha, right? This implies alpha t is less equal to 1. So alpha t is very less, right? So alpha t is very nice. E to the power alpha t, is very less, guys. So very less means that almost e to the power 0. E to the power 0 is 1. Okay. So then this value is going to be e to 1. This value is going to be, and also guys, here you need to understand e1 minus e2 equal to e0 plus h cut alpha minus e0, right? This will get cancelled and this is h cut alpha. This also you need to. This value. So this value is going to be then alpha square upon 100 into t square, right? So this is alpha square t square upon 100. So which option is matching, guys? Option C, alpha square t square upon 100. So this is the answer, okay? I hope you have understood it, guys. Okay, guys, so I'm going to stop here. And before wrapping up the class, I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you for cracking the exams related to physical science. Also, guys, please share my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, guys, so thank you so much. Bye now.